Hello guys! So we continue solving example number 3 involving particles and objects with externally applied forces and acceleration, which is solved based on Newton's laws of mechanics. Let's examine diagram B, where we are also supposed to find the unknown force X and the unknown force Y. The mass of the object is 4 kilograms in this case. The acceleration is 2 meters per second squared to the left as shown. The first force along the x-axis is 18 newtons directed to the left. The second force along the x-axis is x, the unknown force, directed to the right. Then along the y-axis there is 20 newtons directed downwards, as if pushing down on the object. Also along the y-axis, there is the unknown force y directed upwards. And finally, along the vertical axis, the y-axis, there is the force 4g newtons directed downwards, which is the weight of the object. It is 4 kilograms multiplied by gravitational acceleration g. So to calculate x and y, we shall use the equation with Newton's second law, F net equals to ma. And to apply Newton's second law in the direction of acceleration, we have the 4 kilograms mass and the acceleration 2 meters per second squared. So this is along the x-axis. Let's first determine the positive direction along the x and y-axis. Along the x-axis, the positive direction is in the same direction as the present acceleration, which is to the left. So we continue along the x-axis. F net is equal to ma. Along the x-axis, there is the 18 newtons force that is positive since it's directed in the positive direction of the x-axis to the left. And there is the unknown force x, which is negative since it's directed opposite to the positive direction of the x-axis. Those are the only two forces along the x-axis. So 80 minus x is equal to ma, which is mass multiplied by acceleration. Mass is 4 kilograms multiplied by the acceleration a, which is 2 meters per second squared. Then there is 80 minus x, that's equal to 4 multiplied by 2, which is equal to 8 kilograms multiplied by meter per second squared. This is a Newton, so the equation is equal to 8 newtons. Then to find x, we move negative x to the right side and we move 8 to the left side. Then x is equal to 80 minus 8, that's equal to 72 newtons. So x, the unknown force along the x-axis, is equal to 72 newtons. Next, to find the force y, let's apply Newton's second law along the y-axis. Set the positive direction along the y-axis to be upwards, since there is no acceleration along the y-axis. So we set it in the same direction as the unknown force y. Then let's check the forces along the y-axis and sum them up. So F net is equal to ma. There is y positive directed upwards. There is the 20 newtons force that is negative since it is directed downwards opposite to the positive direction. And 4g that is negative since it is directed downwards. This is the weight. Then the equation becomes y minus 20 minus 4g. G is 9.8 meters per second squared, and that's equal to ma. The mass m in this case is equal to 4 kilograms. However, a is equal to 0 since there is no acceleration along the vertical or the y-axis. So the equation becomes as follows. Y minus 20 minus 4 multiplied by 9.8. 4 multiplied by 9.8 is equal to 39.2. So y minus 20 minus 39.2 is equal to 0. Then we move everything beside y to the right side. So y is equal to 20 plus 39.2. That's equal to 59.2 newtons. So it's important to get acquainted with this methodology of applying Newton's second law separately along the x and the y axis to find unknown forces or maybe accelerations along the x and y axis, as in further problems that we may encounter.